Today we are diving deep into the fight against ALS, and we're looking at it from a really fascinating and honestly hopeful new angle, the science of repairing the tiny power plants inside our nerve cells.
Okay, to really wrap our heads around this, I want you to imagine something with me. Picture your body as this huge, sprawling, bustling city. Millions of signals zipping around, supply chains, everything running 24/7 just to keep the lights on.
Now imagine the power plants for that entire city start to flicker and then fail. For people with ALS, this isn't just an analogy. It's what's happening to the tiny energy centers inside the very nerve cells that control their muscles. It's a citywide power failure, one cell at a time.
So, what exactly are these power plants? And why is a little power failure inside a single nerve cell so catastrophic? Let's break it down.
These power plants, they have a name: mitochondria. They are these microscopic little engines inside almost every single one of your cells. And their main job? To produce energy. For nerve cells, this energy it's everything. It is the fuel they absolutely have to fire signals and tell our muscles to do anything, to move, to talk, even to breathe.
So when they start to fail, it sets off this devastating domino effect. First, the nerve cells are literally running on empty. Then, this energy crisis leads to a buildup of nasty, harmful chemicals. Think of it like pollution from a failing factory. On top of that, toxic proteins like SOD1 and TDP-43 start clumping up, basically jamming all the internal machinery. And this whole cascade of failures, it eventually forces the nerve cell to just shut down and die.
But what if you could send in a repair crew? That is exactly what researchers are trying to do right now. They're developing these incredible new therapies designed specifically to get these tiny power plants back online.
And the goals here are super direct. It's almost like a mechanics checklist for the city's power grid. Number 1, boost energy production. Get more power to the cells. Number 2, clean up all that harmful chemical pollution. Number 3, clear out those protein jams that are clogging up the system. And the whole point of all this? To stop the nerve cells from dying and, most importantly, to improve a person's quality of life.
Now, this hasn't happened overnight. The momentum here has been building for decades. The very first clues were found back in the 90s. By the 2000s, we saw the first therapies. And now, here in the 2020s, we're in this whole new era of highly specific treatments, these energy boosters, designed to directly help the mitochondria. You can just see the pace of discovery picking up speed. So who are these repair crews on the front lines? Well, in this next part, we're going to meet the companies and the actual therapies they're developing to try and get that power grid back up and running.
The strategies being tested are really, really cool and diverse. You have therapies like edaravone, which basically act as a cleanup crew for all those harmful chemicals. Then you've got direct energy boosters like CNM-AU8. And others, like what Brainstorm is doing, even use stem cells to support mitochondrial health. Everyone is tackling the problem from a slightly different angle.
But the big question is, does any of this actually work? Well, let's look at edaravone. It's a drug that's already approved, and for some patients, it has been shown to slow down the rate of functional decline by about 20%. Now look, that is not a cure, but it is a tangible, measurable impact. It's real proof that targeting these mitochondria can make a difference.
And here's what that 20% can actually mean in someone's life. For Tom, a 52-year-old on the treatment, it meant more time walking. It's just such a powerful reminder that this isn't about numbers on a chart. It's about giving people meaningful improvements in their day-to-day lives.
Of course, the road to new treatments it's never a straight line. It's really important that we're realistic about the hurdles that researchers and, of course, patients are still up against.
And that brings us to a really critical question. With all this promise, all these different approaches, does every single attempted repair actually work? The honest answer is no.
A tough recent example of this is the story of AMX35. It showed a ton of promise early on, but unfortunately, it failed to meet its main goals in a big, late-stage trial just this year. That was a huge disappointment for the community, and just a harsh reminder of how incredibly difficult drug development really is.
And that failure really puts a spotlight on just how tough these hurdles are. You've got the blood-brain barrier. It's like this natural security shield that's notoriously hard to get drugs past. The disease itself is also so different from person to person, meaning a drug that helps one patient might do nothing for another. And then you have the massive challenges of cost and the simple fact that we still need more long-term data.
But, and this is a big but, despite the setbacks, the field is pushing forward with just incredible determination. So for our last section, let's look at what's coming next and why there is still a very, very strong current of hope.
The future is all about being smarter and more targeted. We're looking at potential new drug approvals, maybe even by the end of the decade. We're seeing the rise of gene therapies designed to go in and directly fix mitochondrial function. And what I think is maybe the most exciting is the move toward personalized medicine. Using things like blood tests to match the right drug to the right patient, and even using combination therapies for a kind of 1-2 punch against the disease.
And this hope, it isn't just theoretical. This is a quote from Maria. She's a participant in a huge ongoing trial for that energy booster, CNM-Au8. For her, this potential treatment meant she was able to maintain the strength in her hands. It's another powerful example of how this research is focused on preserving function and improving daily life, right here, right now.
So, in the end, the fight against ALS is changing. It might not be about finding one single magic bullet. Instead, it's about the steady, determined work of these scientific repair crews. They are working cell by cell to restore energy to a city that desperately needs it. They are, quite literally, turning the power back on. The only question left is, how soon?